and he's about to go up, and I'm going to give him a slow intro. It looks like we're getting ready here. So the name of your talk is a 3D scanner in your pocket. 1 year of Lidar has changed everything in consumer and enterprise reality capture. And Christopher Laan, is Jason your brother here too?
I'm Jason, my brother.
Oh, you're Jason.
My
okay,
brother
my
didn't show up.
apologies. Yeah. Okay, we got Jason here. My bad. So Jason, thank you for joining us, and it's all yours.
Thanks. We're good with the clicker? How are we doing today? I'm just going to give a brief talk kind of about really what's going on with mobile LiDAR and why that's so important. We've all been doing like 3D reconstruction for a long time, especially in the AR and the VR space. But with depth sensors, it really came and kind of changed the industry because it made it very immediate. And I got a lot of people thinking about it again. Now, the technology is not really, I'd say it's still in the prototype phase. It's not perfect. Like, you can't scan something and walk out of here and be like, oh, this is a perfect game-ready asset. And there's a lot, and we're not the only ones in this space. There's a couple other companies. We're 3D Scanner app. There's another great one, Polycam. Metascan from Laan Labs is really good. Metaverse. And then there's a couple others I'm forgetting. Sitescape, EveryPoint. They're all really great apps. If you have a LiDAR-enabled phone, and a lot of them now, they've introduced photogrammetry, I'd definitely check them out. A lot of them are free. Ours is completely free. And it's just something to play with, and if you're in the space, it just allows you to create and work with assets very, very quickly. So I'm really going to talk about how people are using it. We have about 2 million users. Not all of them are active. A lot of people just kind of come on, test it out, and move on. But we have about 300,000 people that use it every month. And so this revolution in kind of this latest wave started in 2020. Apple added LiDAR. They're always kind of a game changer because they have mass adoption. I hate being an Apple fanboy, but when they make something, it just has such ubiquity and uptake that all of a sudden everybody explores it again, and you have everybody thinking about 3D. So now you have people being able to rapidly scan and capture something and make 3D objects about it. And why is this so important? It's important because of kind of like a few different factors that photogrammetry or 3D, the typical 3D scanners didn't have. First, it's accessible. It's in my pocket. I'm walking around with it. It's really easy to use. The cost is fairly cheap. A lot of people already have these iPhones, and then it's, again, we get back to just this portability of just, it's easy. I'm going to have it with me always. If I see something I need to capture, if I'm on a job site or I'm on a film set, I can take a 3D scan of something. And just quick overview of all the technologies, we've had, photogrammetry and drones, we've had high precision terrestrial LiDAR, and now we have mobile LiDAR. These other technologies can produce better assets, but again, there's some key advantages with what mobile LiDAR is bringing to the table. And I'm just going to run through a few different industries and how it's affecting them and how we're seeing our users take advantage of the technology. So I've just thrown up, a few different sample industries here. Everything from shipping and industrial management to real estate to film and TV. And I'm just going to walk through a few different examples here. So what we're seeing across these different examples is some commonalities of how people are really gravitating to feature sets. And the first thing we're really seeing is like scale and measurement. What's so important about mobile LiDAR is you have depth information. And that depth information now gives us a really good degree of accuracy when we're scanning something, and it provides us with basic measurements. Everyone's always asking us, like, well, how precise is it? I usually like to say if you know what you're doing and you've done a few scans and you got your head wrapped around the tech, you can get in the 95%. It's not great if you're like building a marble countertop if you go in and scan an apartment for renovation, but it's really good for a rough assessment. Another commonality we're seeing a lot about is documentation, location. We're seeing this a lot in like the property management space. We're seeing it in the insurance industry. And then, lastly is just this interoperability and sharing. The fact that, I don't need to bring a high precision or a complicated rig out to like a retailer. They can capture something very quickly, from a remote site, and they can upload it to the cloud, and they can share, scans really quickly. So here's just a case study of kind of a road construction company we have using it. So They use it a lot to do site surveys when they're out in the field. They'll scan a construction site in progress, and then they can upload that to the cloud. This is actually displaying on Cesium because that's something they use. But it's tagged with geoinformation. They can quickly see what does this job site look in respect to what else is going out there. So you have this kind of resource management and coordination. And then what's the fun trick is they can come back afterwards and view it in AR and see where this actually exists underground. Here we have, this is actually a Danish company. They do really amazing kitchens, like on demand. So it's just like a CNC setup. So they use it to come into renovations and quickly assess, one of their kitchens going into a place. So it can do, very quickly, this virtual planning and production, this asset coordination and this estimation. Another industry we're seeing using this technology a lot is film and TV, and it's just because of its accessibility. They're using it in location scouting. They're using it, there's a whole segment of that industry called pre-visualization, where they need to collect as much information, and especially 3D information when they get into doing effects afterwards. So, this team is using it everything from, like I talked about, scene continuity, the VFX, the camera info, because if I'm gonna turn this into some crazy 3D set, I need to know kind of the scale. How big is this chair? How big is this lectern? And then, as I talked about earlier, documentation has been a big one. We have a lot of people that are using it in conjunction with like drone, photogrammetry, or here we're showing an old tunnel in Virginia that was inspected, or a car crash. But it's being used in a lot of different ways. Shipping has been another one. We have a few big companies that we've developed custom versions of the software for, or it just makes it really easy for them to capture measurements of objects. I've done something simple here. It's pretty square, but it's really helpful when there's odd shapes. It helps with virtual planning, and virtual loadouts and things like that. Very common. As the technology improves, I think you're going to see this kind of this asset management happening more and more. This is a little video game. I did this myself, but we have a few developers that are using this to quickly capture an asset and use it as like a grease pencil almost. They bring it into Blender. They're able to make a reference object fairly quickly, and then design a video game around it. So really, the common thread I'm getting at here is just there's limitations to the technology. It's not perfect, but people are finding use cases for it now, and they're saying, all right, this is really interesting for what I'm doing, and I can use this in its current state, and I understand it's going to get better and better. And we're moving into this, I hate to say the M word, this metaverse, but this ability to capture. So I have a couple more examples of how this technology also fits into kind of your portfolio of other technologies that are out there. And one of the big ones we're seeing in the construction industry or across film is they have high precision 3D scans. So what you can do is you can merge that data together, where you have a high precision scan you're working with at one point, but you're also working with mobile scans that may not have the accuracy, but it helps you, I'm showing here just a time lapse between a stage of the construction project, but you can see, how the assets have developed. And something else this is really improving is just how AR, the information we work with, because we have more depth information, we're getting improved object recognition, we're getting improved spatial interactions, we're getting improved object interactions. We made a little AR parking helper, to guide people how to back up. But that accuracy we're able to get with this mobile LiDAR, really made that possible. It wasn't really possible when it was just, purely, a SLAM system based on monocular single camera input. Also, where is this going? So this data, it means improved machine learning. So we do a lot of floor plan extractions. It's not perfect. We'll take a scan. We'll look for planes that works well on a small room, or something we're doing here is we're taking a scan of a foot, and we're able to kind of automatically extract measurements out of it. But what's the next big thing? Where is all this technology going? Why is mobile LiDAR so important? I'm going to let I think, Ori and all the, the big boys keep talking about where, the M word. But it's really about we're living in the digital world, and not everything can be professionally captured, and not everything can go through like a 3D art pipeline. So I think we're going to see just improved sensors. I mean, yeah, the sensors that are on there aren't great. I mean, like, I always compare the LiDAR sensor on the current mobile phone as to like it's your 1990s Nokia. Yeah, you can watch a video on it, but it's not great. But it's going to get better, and I think you're going to see, a combination of improved sensors and improved computer vision technologies produce improved, 3D reconstructions. Also we're kind of, we're seeing Android race with Apple to just, we've started a land war in this depth imagery. So I think, that competition is just going to constantly improve what's available to consumers. I saved this for the end, why you might know about us. We've made tons of apps, gotten lucky with a few, kind of our last big hit with Face Swap until Snapchat kind of borrowed that. But we have a lot of, we're constantly iterating, and we live on the, the edge of what technology is. And I think mobile LiDAR and 3D depth is that edge right now. It's not something that's perfect, but it's something that's getting there. And I think we're going to see it more and more in our life and part of daily capture. You saw it with Niantic's, their engine they demoed today. It's very, very impressive, but it still has a long way to go. My brother's not here. This is the two of us. We're a small shop on purpose because we did the whole startup game, and neither one of us kind of loved it. And I guess at this point, I wanted to open up for questions. I know this is a developer track. I kind of kept things light and tech-free, so if anybody wants to ask anything specific, more than willing to jump into something more technical.
Thank you, Jason. Have a round of applause, and then we'll go into some questions here. We got a mic in the middle here. I see a couple of people lined up, so if you want to ask a question, feel free to line up there, and I've also got a mic here.
Thank you for that. I had a question. So I come from the defense industry, and we're really sensitive about our data, especially when it comes to photo. But at the same time, I see the value in being able to capture quickly. Maybe, do you know of any solutions that don't involve us sending our information out to
we're actually already working with some sensitive, and actually we found that the film industry is a lot more hardcore than the defense industry. So we do make a hardened version of this app that doesn't connect with anything. It's actually really funny, but the film industry, like the people that do the Marvel movies, are just, it's insane. It makes the defense industry look like a joke. No offense. But yes, all this processing is done on device. It's not communicating with the cloud.
Is that might be a silly question. Is that an industry thing, or just like something unique to your organization?
No, I mean, there's a few different paths. So the depth data that's collected on the device, you can do that reconstruction without communicating with anything. Photogrammetry, where you're taking that imagery, and you probably heard a lot about Apple's Object Capture API. That's something that you would then upload to probably a remote server and process. But we do make a hardened version of it. The only thing in the current app that communicates with the web is really just Google Analytics, what people are opening. But if you're interested, I can give you a beta that's not connected to anything if you wanted to test out.
Do you have any tips or things for capturing certain objects that might not be well captured with LiDAR, like shiny things or windows?
Well, reflectivity is just always going to be an issue, because you need, basically, always look at it like taking a piece of string, and moving your finger around to know where that point is. You have to think about it, if you're using something shiny, you can't actually hold the string. The string is just slipping around because there's nothing visually to lock onto, is what I normally tell people. There's a ton of things like these sprays that, you've probably heard of them, that will help with the shiny stuff. But, what we see a lot of is just people using it for reference, and then it needs to go through a 3D artist pipeline for that collection. There is a lot of stuff going on with, ML that's, pre-extracting shiny stuff like water and glass and removing that from the images or removing that from the depth. It's something we're working on constantly, but there's nothing right now that's turnkey that I know of, but that's not to say it doesn't exist.
Cool, thanks.
We got time for one or two more questions if anybody has one.
Was that boring?
We got one here.
So you mentioned your device. Are you speaking about like an iPhone device? Or?
Yeah, I'm just speaking about the iPhones with the LiDAR in them. So, the iPhone Pro 12 and 13 and the iPad Pro with LiDAR, they've named it very confusingly, has a little sensor here. And we also use the true depth sensor as well. That's another capture methodology that I didn't get into there, but that's the one that they use for the face recognition. So you have like these different depth sensors. You can use them as different pathways to do to this 3D reconstruction. It's the general term I use.
Hi, thanks for the great presentation. What do you expect the demands on augmented reality LiDAR would be compared to, for example, a cell phone? Would it have to be more precise or less precise?
For AR,
Yes.
we found AR to be less precise because people aren't concerned. I mean, it depends what you're using AR for. Sorry, a lot of people are using AR for construction or templating where it needs to be very precise. I think AR in the gaming environment, it's more just does it have that visual continuity that makes the game feel or the experience feel immersive, where it's for construction or something. So we use a lot of AR in construction, and we then line up a high precision LiDAR scan from like a Faro or a Leica or a Regal with a mobile to get that precision that's needed in that environment. For gaming, it doesn't seem to be as accurate. It's more about occlusion and things like that. You've probably seen a lot of the other developers demo.
Any idea how the HoloLens and the Apple iPhone compare?
I mean, the HoloLens, sorry for anyone that works with Microsoft, I think is just this camera duct taped to the side of your head. There's nothing really there. I'm sure Microsoft will make something better, but the iPhone is a much more powerful device with a lot better set of sensors in it. And I'm not just kind of giving Apple kudos, but it's just the HoloLens is a few years old now.
Speaking of Apple versus its competitors, what would you say there is in the Android space that's comparable to what the pros are doing now or is on the horizon?
No, there's some great depth sensors. Samsung has some really good ones, but they haven't really opened them up. And the whole problem with Android devices, if any of developers in the room, there's the disparity, the heterogeneousness in the devices that are out there just makes it really difficult to evaluate. So yeah, you can make something for one version of one device that has a good depth sensor in it. But usually, probably a lot of us got on with the Google Tango, and then Google got rid of it. And it was a great device. It's still great. I know some people that hoard the things because they, have such good 3D. But yeah, Android, is in it, but they don't seem to be in it to win it.
Thank you, Jason. Yeah.
All right.